If you put all fungal infections together, we are talking about 1.6 million people dying every year.
Welcome to the Knowledge Archives podcast. We're a group of students on a mission to learn from as many different disciplines of knowledge as possible. I'm your host, Madhav Malhotra, and today I'm glad to be joined by Dr. Marcio Rodrigues, senior researcher at the Oswaldo Cruz Foundation in Brazil. Dr. Rodrigues has studied fungal diseases for decades, and these are currently neglected by the pharmaceutical industry. Today, we talk about why fungal diseases are especially hard to treat. Thank you again so much for taking the time to join me today. I am very excited personally about this topic, and before we get started with all of the technical details, I'd just love to hear about you. So, would you mind introducing who you are, where you're working, and how you got started in this area?
All right. Thank you so much for this kind of opportunity. I really appreciate it. My name is Marcio Rodrigues. I work in Brazil. I work for a federal foundation for research in Brazil that is called the Oswaldo Cruz Foundation. It is most commonly known as Fiocruz. Fiocruz is the largest and most important health institution in Brazil for research. And in Fiocruz, we have a long tradition of fighting many different neglected diseases. So in my group, we investigate fungal infections in general. So we are interested in discovering how fungal cells can cause damage to the host. And after that, we can think about solutions to fight fungal diseases. In our lab, we are really interested in a treatment that is called repurposing, which is something used when you have a drug that is used to fight some disease, and you can then use this drug to fight other diseases that were not considered initially. I started in this field something like, 25 years ago. And for this whole period, I have been working with a specific pathogen that is called Cryptococcus. Cryptococcus goes to the brain and causes a very bad meningitis that kills people, unfortunately, very efficiently. Every year, 200,000 people die because of cryptococcal meningitis, mostly in Africa. And if you put all fungal infections together, we are talking about 1.6 million people dying every year because of fungal infections.
I bet a lot of people, they don't know about that because especially in developed countries, it's rare to see people who have serious fungal infections. And you mentioned how these infections are neglected right now. To start off, it might be very useful to just hear about the history of this field a little bit. So in the past, maybe there wasn't as much focus on fungal infections infecting humans. Could you talk about why that was and how that's changing?
Oh, that's totally true. So if you think about, for example, viral diseases, bacterial diseases, and parasite, and diseases caused by parasites, our society knows that they are important. Actually, this kind of knowledge has been available for more than a century, actually more than centuries. Fungal infections, in general, they are not dangerous to the human host. In general, of course, there are exceptions. But for a fungal infection to get serious and, to cause patients to die, in general, you need the host to be susceptible to this kind of infection. And in general, when you're immunocompetent, which means that your immunological system is working well, you can control fungal infections. Of course, you can have, for example, superficial infections on your nails and hair and skin. But in general, for a fungal infection to go disseminated, which means that it can go anywhere in your body, you need some kind of immunosuppression, which means that you have an immunological defect, and then you cannot control the fungal infections anymore. So for many decades, fungal infections were actually exceptional cases in not too many people. But then in the 80s, when AIDS was a real problem to the world, the number of cases of people susceptible to fungal infections increased a lot. Actually, it is not because it's AIDS, it's because of the immunosuppression. For example, if you're receiving an organ and then because of the transplantation procedure, you need to be immunosuppressed because then the chances of rejecting the organ are going to be smaller. In this case, you need to take an immunosuppressor, and then you're going to be susceptible to a fungal disease too. So in general, serious fungal infections, they are connected to some stage of immunosuppression. So from the 80s until now, the number of people with this kind of condition increased a lot. And then the number of people dying because of fungal infections increased a lot. It was a giant problem in the 80s and the 90s because people didn't know how to control, for example, the immunosuppression caused by AIDS. And then if you think about, as you said, the developed world, it is not a huge problem because this kind of control is already functional. But if you go, for example, to the sub-Saharan Africa, the number of people there immunosuppressed because of AIDS, it's just huge. And that's the reason people are dying there in incredible numbers.
Okay, so I see that the 80s were a big turning point for when the problem became really serious. Did the solutions that we used, did that also change a lot after this?
Of course, everything is connected. If you don't have too many patients dying because of fungal infections, the pharmaceutical sector is not interested in developing tools to fight the diseases because, there will not going to be too many people buying drugs. In general, the funding agencies, they think the same because if you don't have a high number of people with that kind of disease, it is not too important and so on. Besides this whole situation, you have something like 80 years of, the scientific community during 1 century, for example, they were studying viral infections, bacterial infections, and then they developed vaccines, drugs, and they understood better how the pathogen caused the disease. And with fungal infections, this kind of thing, it started intensively 80 years after viral diseases and bacterial infections and so on. So we need more knowledge about fungal infection. We need to generate more knowledge about how they cause damage to the host, because then we're going to understand better. And it's not, for example, for coincidence that you have much more therapeutic alternatives to fight a bacterial infection than you have for fungal infections, because, we took longer to start studying this kind of disease. Because of this same situation, some of the tools that you have to fight fungal infections, they are just too expensive. It is not only a matter of developing a vaccine or a new drug. You need something that poor countries can afford. Otherwise, the problem will remain the same.
Yeah, I think that's a very important summary of how this problem is changing and becoming more serious. Aside from the fact that many more people have weaker immune systems today, I'm also curious, there's another barrier that we used to have for preventing fungal infections, which was the fact that they couldn't live inside our bodies because the temperature inside our bodies was too high. Could you talk a little bit about how that is changing and affecting the seriousness of this problem?
Well, this is actually a very important topic in this field because right now we are facing emergencies because of this relationship between temperature and fungal infection. So the one thing that you need to keep in mind is that most of the fungal species, 99.9%, they are in the environment. So in general, fungal species, they are not looking for a human or an animal host. In general, they are happy in the environment, and there they face temperatures that in general are lower than those that they found when they infected. Actually, most of the serious fungal diseases, they're caused by species that are there in the environment. And then when the human host faces this fungal species, they have mechanisms to resist within the fungal host. And one of these mechanisms is temperature resistance. And then they cause damage to this host. So, for example, if you think about the fungal species that is going to be pathogenic for humans, one thing that is not negotiable is it has to be able to grow at 37 degrees. And most fungi, they don't do it. So that's why the number of pathogenic species is really, really, really reduced compared to the number of fungal species that you have in nature. Say something like a few dozens of species can cause damage to the host, and millions of species just remain in nature doing what they have to do there. But this kind of situation changes all the time. because of the pressure that we humans put on environmental microorganisms, and then they adapt. For example, you certainly heard about an emergent pathogen called Candida auris. Candida auris is a big problem because it is a fungal species that is resistant to most antifungals that are available right now. Some of the species are resistant to at least 2 different antifungals. So it's really hard to fight an infection like this. And the mortality associated to Candida auris can reach 70%, 70. So if you think about a mortal fungus, and then you don't have the number of tools, the appropriate tools to fight this kind of fungus, you're going to have a real health problem. It's all over the world. It is in Brazil. It is in America. It is in actually now all Americas, Africa, Europe, Asia, everywhere. And why is such a kind of pathogen emerged suddenly? It was discovered in 2009, which is nothing in terms of science, and now it's a huge problem. So there is an association between global warming and selection of pathogens in general. This is something easy to understand. It works like this. So you have, microorganisms in general, fungal species included. They're living in nature, and let's say they like to live at 25 degrees Celsius. And let's say that the local temperature increased 1 single degree. So all of them that use it to resist until 25, if you increase the temperature, they are not going to be well. But let's say if you have 10 different species and one of them resists to this additional degree, all the others are going to die. Of course, I'm simplifying. And one fungal species that was splitting food with all the rest, it's going to be there with all the food for itself. And then the way it replicates is going to increase. So one species that was sharing space with the other 9 is going to have everything for itself. And then it becomes dominant. And then you put one additional degree and another. So after all, it becomes a pathogen because it acquires a mechanism to resist to higher temperatures until it meets the human host. And then you have something new that you're not expecting. You don't have the right tools to fight it. And this is going to happen more and more frequently. Today, Candida auris is the problem, but we are going to have more. And this is not only for fungal species. All microorganisms that are living in nature, they are candidates to face this kind of process.
So the 2 key issues that we're facing, more and more people are getting immunocompromised. Their immune systems are becoming weak because we are being faced with many different diseases. And on top of that, before, only a very small % of fungi could actually infect us humans because of our high body temperatures. Now, that's increasing. So we're facing new species that we never had before.
Yeah, that's right.
And we've been talking about antifungals for a while now. Could you quickly define what types of antifungals do we have? How many are being developed right now? And why do we have so many fewer antifungals than antibiotics?
Yeah, that's a good question. So first of all, you have only a few classes of antifungals that are used in clinics, and most of them are based on a difference between our cells and fungal cells. So once again, everything is connected. First thing that is important to keep in mind is that when you have a drug to fight an infectious disease, you need this drug to damage the microbe without damaging us. This is really important because I know it's going to look weird, but it's totally true. Our cells are really similar to fungal cells, not in the way they look, but in the way they work. So we are all eukaryotic cells. And because of this similarity, the organelles and the way the cells operate, they're really similar. And this is the first difficult that you find to develop antifungals. It is hard to find something that kills fungal cells without killing us. And this is actually confirmed when you see the way things work, because antifungals in general, they're toxic. Of course, they're based on differences between fungal cells and our cells, but this kind of difference, it is not that evident to make sure that the antifungal is going to target fungal cells without doing nothing to us. So if you think about, for example, antibiotics against bacterial infections, this kind of problem doesn't exist because bacterial cells prokaryotic, and they are completely different cells. So it is less complicated to find targets in bacterial cells. This is one thing. The second thing, we discussed it already. So we took longer to invest time and money to do research about fungal infections. And this kind of lag generates, of course, a gap in the knowledge that you have about fungal infections. And you have only a few classes. In general, they fight the fungal membrane. All cells, they have membranes. And if you compare the membrane of a fungal cell and our membranes, there is an important difference. That is the presence of a lipid called ergosterol. Ergosterol is the counterpart of the mammalian cholesterol that is in our membranes. So most of the antifungals that you have, they affect the synthesis of ergosterol, and then the membrane is going to be messed up. Or they look for ergosterol in the membrane, and they bind to ergosterol, and they open holes. Once again, ergosterol is not cholesterol. They are different, but they are not that different. So sometimes you have, side effects that you wouldn't like to have. But there's another important difference between the fungal cell and our cells. Fungal cells, they have cell walls. We don't have cell walls. So we have our membrane, and that's it. Fungal cells, they have the membrane too, but they have the cell wall on the top of the membrane. And this cell wall is really unique. You have drugs that can affect the synthesis of the cell wall, but unfortunately, they don't work against, most of the pathogens. So it's always complicated. You have a few options only. Sometimes they don't work well. And just to put another problem over the situation, you have a very important antifungal that is actually really effective called amphotericin B. Amphotericin B was discovered in the 50s, last century. It is really effective. It is a good antifungal, but it's really, really toxic to our kidneys. So one way to reduce the toxicity of amphotericin B is to use a lipid formulation. You put this antifungal inside the lipid formulation, and it gets more effective and less toxic, but it's just too expensive. So you don't have too many of them. You have better formulations, but sometimes when you have better formulations, they are more expensive. And you have some good antifungals like the azoles. They interrupt the synthesis of ergosterol. They are not expensive, but they are really associated with resistance to the antifungals. And just to go to the last point, you asked about antifungals being developed. There are not too many. I don't know the exact number, so I don't want to give you a wrong information. But if you have 10, you're being optimistic. It's something like this.
Yeah, it's definitely a lot lower than antibiotic development. I do have one question here before we move on, which is, if we've had an agricultural sector for so long and they've faced fungal outbreaks, is there any chance that the tools that they've developed, they might be able to help us when it comes to humans?
Yes. Sometimes, you can actually use this kind of information or molecule and adapt it to the use against the fungal infections, but there's another side. So these drugs are being spread out in the environment for many years. And keep in mind that human pathogens, fungal human pathogens, they are in the soil, in the shelves of trees. So it is really frequent that they face this kind of drug. And sometimes you're going to get infected with a fungal species that is already resistant to this kind of drug because, you had, like we're discussing about the temperature, you had selection of resistant strains before they meet humans because the drugs are being spread out in the environment. So there's also actually scientific evidence that this kind of drug, they can turn fungal cells more aggressive when they meet the human host. So it is never a good idea to indiscriminately use chemicals or physical agents in nature because, many of the things that are going to cause damage to the host, they come from nature. So you have one important genera of fungal pathogens that is Candida that is already inside us, but all the others, they are in nature.
So to say that back to you, it sounds like the agriculture industry, they already had their own set of problems with resistance, so
Yes.
They can't really help us now.
Well, we never know. You need to test, but the concepts, both are valid. Yes, you can find tools there. Actually, it's under investigation. And then you can think about one single drug that could work in these different hosts. But the other side is that, you can always select something worse because the drug was already there.
I guess we've had a lot of negativity so far in the podcast, so it would be great now to talk about all the different promising technologies, solutions, whether it be like a medical drug or like a policy.
Yeah, we talk about a lot of negative stuff, but let me tell you that the scientific community working to understand fungal infections, it's just great. It is really vibrant, really friendly. You don't have, too much competition. So in general, people talk a lot and they share tools and they share knowledge. You have some important societies, like, for example, the Medical Mycology Society of the Americas, that is always discussing this kind of problem. So you have a nice community thinking about the way we're going to control this kind of infection. For example, more than 100 years ago, there was this concept that is widely known of serum therapy that was revisited to be used against fungal infections, actually infectious diseases in general. And now you have monoclonal antibodies being tested to control fungal infections. And apparently you have some of them that are really promising. You can connect, for example, drugs with radioactivity, and then you're going to target your radiation just to the tissue that is being infected with a fungal pathogen. The results are really promising too. You have people, for example, many different groups thinking about repurposing. You have some nice candidates too. And you have this kind of people that we need to stimulate developing new drugs. These guys, they're really brave because, it's really hard to find investors willing to put money to develop a drug that is going to be sold to poor countries. But, a fungal pathogen doesn't ask you if you're rich or poor. When you have a disease, it's going to kill people independently on the social status. So fortunately, we have people that understand this kind of situation. We have institutions that understand that this is important too. And I can tell you, in terms of qualification, good science, we have a lot of nice people in the fungal field working hard to generate tools that they will be able to control this problem. So I think we're going to get there.
And for anyone feeling inspired, they want to be working in this field over the next decade and so on. What do you think are some neglected areas of work that we need more people working on?
That's an important question. So some of the fungal infections, they cause problems, for example, in many different countries and developed countries, and you already have people with a nice look over this kind of infection. For example, candidiasis, it is a disease that affects poor people and rich people too. And of course, we cannot call, for example, this kind of area a neglected area because you have investment. You have, for example, different governments that already know that it's important to put money on this kind of research, and they are already doing this. But if you think about, for example, other areas that affect poor regions of the globe, then it's a big problem. For example, sporotrichosis, it is a disease that affects your skin, not the surface of the skin, but inside your skin. And you have diseases, for example, like paracoccidioidomycosis. It is a complicated name for a lung disease. If not diagnosed well, you can think there is a bacterial infection. If you're going to treat it like a bacterial infection, there's not going to be any effect. And for example, histoplasmosis is a big problem because it looks like tuberculosis. And if you're not aware that it could be a fungal infection, you can lose patients because of a wrong diagnosis. And if you go deeper, there are neglected diseases like chromoblastomycosis. If not diagnosed early, you can have a patient that has to deal with it for decades. Can you imagine you have an infection for 30 years without the proper treatment? Of course, this is not related to health only, but to social exclusion too, because the lesions can be really ugly, and it's really hard to find a position to work and to interact with people when, for example, you have a lesion that is really apparent and people don't know what it's about. It's a big problem. And recently, we heard about mucormycosis that was related to COVID-19 too, which is a really aggressive disease that can destroy your tissues if you're not diagnosed and treated correctly. And this is not only true for people in general, but for the medical community too. So if the physician is not aware that situations like this can be caused by fungal pathogens, of course, they will never treat it correctly. So it is important to bring some awareness to this area, and not only to people in general, but for the medical community too.
Mm. And if you could give like a estimate on the number of people affected by those four diseases that you mentioned, would it be closer to 10,000, 100,000, a million?
So I would say that it's a few thousands.
And we talked about these diseases as like the effects of the current system we have. But to think about those two causes that we talked about earlier, are there any initiatives that you know of that specifically focus on, well, okay, how do we tackle these causes before, we get these effects?
Yeah, there are. So I would recommend you to take a look at the Global Action Fund for Fungal Infections. It's called GAFFI, GAFFI. There, you're going to find all the initiatives that are under development to control fungal infections. Because I am a laboratory scientist, the way I think is, the cell membrane, the drug, the mechanisms of action. So it is different from the real world. And we need to give value to these people that go there to face the problem and to think about, for example, not only about developing a new drug, but facing the social problem related to this kind of disease. So it doesn't matter if you have a new drug, if you don't have a hospital to accommodate these people to have them treated with the appropriate drug. Because of this scenario, it is important, of course, to discuss the basic aspects behind fungal diseases, but you need to discuss the social aspects too. There are others, but I really recommend the GAFFI because there you're going to find everything together. Not only the molecular problems behind developing a new drug. So what I think we need is something like the GAFFI is doing to connect the social problems with, let's say, the infectious disease problems, and to put all together and to understand that we need different initiatives to move forward.
Yeah, you've said that a few times throughout the podcast. It's all connected, and I really appreciate you explaining everything simply. I think that's a skill in and of itself, but also comparing that with, what else is out there to discover. So I'll be sure to include some of the links that you mentioned in the description of the podcast. And I want to thank you for taking the time to join me and explain all that today.
Thank you for opening space for this topic. We need it more. So I really appreciate that you're doing this.